I welcome you all for the second video session. In the second video session, we are going to see about machine learning and its application. Machine learning and its application. Before getting into this topic, and we need to know about what is meant by artificial intelligence. We can split this artificial intelligence into two terms, that is artificial and intelligence, that is feeding the intelligence into the machine in an artificial way, so that the intelligence which we fed can make the machine to understand, reason and plan by itself. And it is one of the booming technique in this present world, and it is used in many fields, such as in the slide we can see that artificial intelligence being used in many fields like decision making, deep learning, simulation modeling, machine translation, robotics, internet of things, image analytics, and visualization, natural language processing, etc. And it is one of the booming techniques, and it trends in this real world, and many fields being making use of this artificial intelligence. And we are getting into our topic, that is machine learning. And machine learning is nothing but learning by itself, that machine learns by itself, so that the ability to learn by itself without being explicitly programmed. It is explicitly being programmed by the human. It is used to think by itself by learning and make its prediction by its own. And this would be the definition which had been explained in the previous slide. And for this definition we are going to make use of one example, and here we've been gathered the data of particular people, that is 10 data of a 10 individual person been taken, and their height and the weight been taken, and that been plotted in a graph xy axis, and height been taken in x axis and weight been taken in the y axis. And we are going to draw a simple line to predict weight based on the height. A simple line could be w equal to weight equal to height minus 100, and we need to know that weight should be in kgs and height should be in centimeters. And we are going to see the example here, and which is used to make a prediction based on the lines which based on the data points which we've been plotted. Our main goal is that we need to minimize the error by reducing the distance between the esteemed value and the actual value. Our main aim is to reduce the error and make them as small as possible. And decreasing in this diagram, we can see that we need to decrease the error between the actual and the esteemed value and improve the performance of the model, so that it is better. Our model will become and will conclude into a better conclusion. And machine learning faces many types of problems like classification, regression, clustering, association, rule learning, structured output and ranking. Out of all the problems, we are going to discuss here few problems which a machine learning faces. And the first problem which the machine learning faces is classification. And classification is nothing but it's a type of a model which is used to attempt to draw some conclusion from observed values. And it is used to classify. When we put the data points in a random way, it use some strategies or heuristic functions to classify all the data points based on the different outcomes and the different labeled values. And next problem which the machine learning faces is regression. And regression, as we all know, that is a type of a mapping function which is used to map the linear regression values. And the best part is that it tries to fit the data with the best hyperplane which goes through these points. And in this slide we are going to see the comparison between the classification and the regression. And when we see with this classification and regression, and both are the mapping function. And the first point is that the classification, it is a type of mapping function used for mapping of values to predefined classes, but for regression it is used to map the values to a continuous output. It involves a discrete value, and regression involves a continuous value. It is a type of unordered predicted data. Here it's type of ordered predicted data. An accurate value will be get through this classification, and this regression, the measurement of root mean square values being used. And some of the algorithm used in classification or regression, logistic regression, decision trees, and the algorithms used in regression or regression tree and linear regression algorithm. And here an example which shows the comparison between the regression and classification, where random of a few statement been taken. Out of the statement taken, we are going to segregate which are the statement will comes under the regression and which are the statements will come under the classification. As we all seen that we are going to predict out which are the things which is comes under the regression and classification. And as we have seen in the previous slide, based on the difference, the segregation between the regression and classification being pointed out of all the statement taken. Another problem which the machine learning faces is a clustering. In simple term, the clustering is nothing but grouping of data, and it is a task of dividing the population of data points into a smaller groups. That is, same group of data items will be grouped in one similar group, and the dissimilar data points will be grouped in a other group. And it is a collection of objects on the basis of similarity and dissimilarity between them. And clustering being used in various fields like marketing, biological field, libraries, insurance, city planning, earthquake studies, etc. And one of the key terms which we need to know when we used with this machine learning is dimensionality reduction. Dimensionality reduction is the feature which is used to find out a correlated data items. Hence, we can reduce the redundancy in the data items. It is a process of reducing the number of random variables under consideration by obtaining of principal variables. It can be divided into feature selection and feature extraction. And whenever we are working with this machine learning, it involves 7 steps that need to be followed. And the step number 1 is that we need to select the research goal, and step number 2, make the hypothesis, and step number 3 is that we need to collect the data. Step number 4, we need to test our hypothesis. Step number 5 is that we need to analyze our results. 6, we need to reach into a conclusion, and last step is that we need to refine the hypothesis and repeat for the better resolution of the result. And we have 2 types of machine learning techniques: supervised machine learning and unsupervised machine learning. Supervised machine learning is that here we have the input set of records with output data. That is, in other words, we can say supervised learning is a type of a learning that is been working under the supervision of someone, that is, would be teacher or someone. But in unsupervised learning, we don't have any supervision, and also the pattern or structure found in data and labeled approximately labeled data has been used in the unsupervised learning. And here we are going to see what are the various algorithms being used for the supervised learning and unsupervised learning, and also we are going to see the difference between the supervised learning and unsupervised learning. And the input data taken for supervised learnings are known and label data, but here in unsupervised learning we are using an unknown data as an input, and it is very complex. Supervised learning is very complex when compared to the unsupervised learning, and the number of the classes are known in supervised learning, number of the classes are not known in unsupervised learning. An accurate and reliable result we get through this supervised learning, and moderate, accurate and reliable result we get through this unsupervised learning. And here we are seeing about the various algorithms which is being used under the supervised and unsupervised learning. And these are the machine learning algorithms used under supervised regression, that is simple multiple linear regression, artificial neural network, ordinal regression, Poisson regression, etc. And similarly supervised two class and multi-class classification, artificial neural network, decision tree, forest and jungles, support vector machine, perceptron method, Bayesian classifiers, nearest neighbors method, etc. And unsupervised we use a k-means algorithm and hierarchical clusterings and anomaly detection, SVM for one class, and PCA are used. And firstly we are going to see with the naive Bayes classifier. Naive Bayes classifier is a type of classifier which make use of Bayesian rule or Bayesian law. And here, in order to make it clear, we are explaining this naive Bayes classifier by considering two people, Alice and Bob, and we are going to compare the combination of the both using certain prediction values. And here we made probabilities of both the Alice and Bob using the key terms, that is love, wonderful and great, and wonderful, love and deed. And based on Bayesian theorem, all the probabilities and the combinations of data been made, and the probability for both Alice and Bob is found using the Bayesian theorem. And based on the outcome with the higher probability, the output is found. And it's also powerful algorithm used for naive Bayes classifier is one of the powerful algorithm used for real-time prediction, text classification and spam filtering and recommendation system. And nextly we are going to see with the support vector machine. And support vector machine is nothing but as a discriminative classifier used to separate the hyperplane. In support vector machine, a training set of data which would be in the form of supervised learning is taken, and we are going to draw the hyperplane, a line dividing a plane in two parts, where in each classes a lane either side. And here the data, two labels of different data items being taken and drawn in a graph. And main aim of SVM is that to separate the different points using the hyperplane. And nextly we are going to see with the decision tree. Decision tree is the most popular machine learning algorithm used, and here it is used for both the classification and regression problem. And we need to gives a simple understanding about the data and makes a good interpretation about the input data based on the human level thinking. Here a decision tree is made based on the input data which being taken in the table. It contains 4 columns with an ID, age, car type and class, and based on this a numerical and categorical value, a decision tree is drawn, and the prediction at the lowest level. The first root node is highest level and the lowest level is a leaf level, and based on the decision taken on each levels, the final root level is drawn, and based on that the decision is made by the user to carry out their way. And next thing we are going to see algorithm we are going to see is k nearest neighbor algorithm. And k nearest neighbor algorithm is a type of supervised machine learning algorithm. It is used for both classification and regression, and used to predict a cluster that the new point will fall into. And this would be the steps. There are various steps followed in k nearest neighbor algorithm. And step 4, we have 4 steps. The first step is that, and we need to choose the value for k, and k should be an odd number. And step number 2 is that we need to find the distance of the new point to each of the training data. And step number 3 is that we need to find a k nearest neighbor to the new data point. And step number 4, a new data point belong to the class that has the most neighbors is being drawn and being given as an output. And next important machine learning algorithm is deep learning. In deep learning is one of the important term which we been used in the machine learning, artificial intelligence, and here we are formalizing the functionality of a brain shell called a neuron, which led to the concept of artificial neural network. And based on the working of our brain, all the functionality of this deep learning being transferred, and that categorization of study is said as artificial neural network, which plays a vital role to receive the input and apply it an activation function along with the threshold value. And here we are seeing with a comparison between the machine learning and deep learning. In machine learning, the feature extraction and classification being done in two steps, where in deep learning both the feature extraction and classification combine together in a single step, and which produce the efficient output. This would be the basic architecture of the deep learning. And dendrites, nucleus, cell body, axon, and the axon terminals are used. Dendrites is nothing but the input terminal which brings the input signal, and the nucleus, that is said as in soma, that will act on behalf of the CPU, which combines all the input values. And axon would be like an output terminal which used to carry out the output signal from the nucleus. Basically all the input values of it and fed and applied with an activation function. Based on the activation function, a threshold value is fixed, and based on this threshold value, the output will be generated and being sent to the output terminal. And this would be the layers which is used in the deep learning. And the first layer is said as an input layer, followed by the hidden layer, and lastly an output layer. And each layers contains one or more neuron, and the same function which been explained the previous slide is being used in the all other functionality to produce the output terminal. And data dependency, as we all know that it is one of the important key term being used in the machine learning technique, and it determines the performance based on the data sizes. As the data sizes increases, the performance in the deep learning technique will get increase. And what are the various requirement to increase the data size, we are going to see in this small slide. And hardware dependency, it's also another important term used in deep learning algorithm, and it is dependent on high-end machine, while machine learning algorithm can work on low-end machine as well. Basically it includes GPUs with an integral part of the working, and GPUs are required as they perform a large amount of matrix multiplication operation. And various recommended engine used for deep learning are Facebook, Netflix, LinkedIn, Amazon, Google, and YouTube. And text sentiment analysis nothing but one of the natural language processing research, and it is entirely used to deploy the model on the text in your app to extract the high level information, and it is used for evaluating the sentimental polarity in the comment section or extracting meaningful topics through named recognition models. And chatbot is one of the application of deep learning. As we all seen here, it is used as a pillar for the next generation interface on the web. Chatbots can be trained with a sample of dialogue and recurrent neural networks. And this would be the basic architecture which the chatbot works on, and artificial intelligence, and which lead to the processing. An outcome is produced, and the outcome can be in the form of natural language processing, predictive analytics, and the sentiment analysis. And image recognition is also the one of the application in the machine learning, and image retrieval and classification are very helpful for the utilization of application images, and it is used to segment and classify the video data, and also it includes recognition models to sort the images into different categories, or using auto encoders to retrieve images based on the visual similarity. Thank you, and I hope this video session would be useful to you, and I will meet on the next video session. Thank you.